Okay, let's look at vertical stretch and shrink. So this is using the information that we've learned for our parent functions and the horizontal and vertical translations that we've already learned as well. So vertical stretch and shrink. Let's start with the graph of f of x equals 2 absolute value of x. So what is our parent function here? Our parent function is absolute value of x, okay? Remember that anything multiplied, added, or subtracted, if you take all that away, that's going to be your parent function that's left. All right, what does the graph of absolute value of x look like? It's a V shape with that bottom being the origin, okay? So we know that the origin is going to be down here. That would be where our parent function starts. However, normally that parent function would go up one, right one, and we'd have a point right here. So I'm just plotting this. You would not actually plot this in the computer, but I just want to show you in the comparison. And the other point would be here. So we kind of have an idea of what the shape should look like. Would that be? What does the 2 in the front do? What does the 2 do? First off, this is not added or subtracted. Okay, it is in front of the entire parent function and it is multiplied. So because it's multiplied, that means that every y value that we get, we're multiplying by 2. So let me give you a quick example. If I put in x value of 0, I get out 0 when I do the absolute value. So here, the absolute value of 0 is 0. But then I multiply it by 2, that one is 0. So this one actually stays at the origin. So this one's not picking up and moving, it's changing its shape. You'll see here with this next one. Okay, so here, let's say we have an x value of 1 and I plug that in. So the absolute value of 1 is 1, but then I multiply it by 2. So 1 times 2 is 2. That means I have the point 1, 2. So instead of it being here, it's going to be up here. And the same thing is going to happen if you do -1. Absolute value of -1 is 1. Multiply that by 2. And now we've got 2. So we've got this shape. Is it still a V shape? Yes. Okay. But notice that normally it would only go up to here, like to the level of 1. But this is going up to the level of 2. Like its height, whenever you go 1 unit over, is up to 2. So this 2 in front, what happens to the parent function graph? This is called stretching. So we are stretching, and specifically, it stretches vertically, up and down. Okay? And a lot of students will be like, well, it gets skinnier. And it does. You're right. Like, if I was to push in the sides, it does seem like it gets skinnier. But I'm not asking in that direction. I'm asking vertically. So what I mean is if I hold on to the origin and I pull it from the top, that is how it's getting skinnier, okay? I don't want you to think about pushing in the sides. I want you to think pulling from the top. That's your vertical direction. All right? So that would be if there's a 2 in front, it goes up faster. Instead of just being 1, 1, we've got 1, 2. What do you think happens if I looked at 1/2 in the front of absolute value of x? So I still have that parent function absolute value of x. What happens if I plug in 0? We know that our parent function is absolute value of x. So absolute value of 0 is 0, and then multiply by 1/2, I get 0. So I'm still have that point there. That's okay. But what happens when I do 1? The absolute value of 1 is 1, but then times 1/2 is 1/2. So we're actually right there, halfway. And that same thing happens on the left side. Okay, and then when I draw this graph, it goes out much, much wider. Okay, so this is 1/2 absolute value of x. And its height, when you go to 1, is just up 1/2. So our regular parent function is 1, 1. The 2 in the front does 1, 2. The 1/2 in the front is 1, 1/2. So it's only half the height, okay? So what does this happen to, or what happens to the parent function graph? It shrinks. It shrinks vertically. And again, a lot of students will say, well, it gets wider. Why does it shrink? again, this is where vertically comes in, because this is like, I'm going to erase this so you don't have to draw this, but it's like pushing it down. Okay, so if I was to push this down, then it is going to get wider. And I think about little kids. I know this is going to be kind of a crazy example, but let's say, do you remember playing with Play-Doh and you have a brand new thing of Play-Doh and you open it and you dump it out and you're like, oh, and it keeps that perfect little shape. And then a little kid comes by and it smashes it on the top. That is pushing it down, but what happens to the Play-Doh? The Play-Doh smushes out the sides. That is exactly what happens to this when it shrinks. It's shrinking vertically, but it is smushing out the sides. So that's why we get that wider graph. Okay? All right, so that was stretch and shrink. So a number that is, how do we know the difference? Well, just think about it in respect or with respect to 1. Compare it to 1. Is that number bigger than 1 or is it less than 1? If it's bigger than 1, you're going to be stretching because you're going up higher. If it's less than 1, typically a fraction in between 0 and 1, then you're going to be shrinking because you're going to be down in that fraction territory. Okay? All right, so that's another type of transformation, our stretch and shrink vertically. Let's look at our next type. Let's look at the graph. F of x equals the negative the square root of x. Negative square root of x. So what's our parent function? It's square root of x. What does that look like? It looks at the origin. It looks like a little ray or half a parabola laying on its side. So normally it would be here. What happens when I put a negative in front? So again, I would plug in 0 and plug in 1. So when I plug in 0, the square root of 0 is 0. Put a negative in front, that doesn't change anything. So we have 0, 0. Okay, this, let's do 1. If I do 1, the square root of 1 is 1. But I put a negative in front, I get negative 1. So I actually plugged in 1. And I got negative 1 out. So let's plot that point. 1, negative 1. We're down here. So instead of this going up and to the right, it's going to go down to the right. So this is negative square root of x. So what happens to this parent function graph? Normally, and you don't have to plot this, but I'm going to show you real quick. Normally it looks like this. That's square root of x. But this one flipped down. And what did it flip over? It flipped over the x-axis. So what happens to this parent function graph? It reflects over the x-axis. So a negative in front reflects over the x-axis, okay? In front, you've got your parent function, but you just stick that negative in front. All right? Well, let's look at what happens when we have the square root of negative x. Where's the negative here? It's on the inside, right? If I circle that square root of x, we've got the negative inside that circle. So what happens here? Let's again try 0 and 1. And for most of these functions, that will work. Let's see if it works with this one. If I do the square root of negative 0, that's still going to just be 0. So I've still got this point here. But if I do the square root of negative 1, see if you remember what that is. Do you remember it's I? So we're not going to graph that. We're not going to graph I. So we need real numbers here to work with. What can I plug in to x right here so that I actually get a number out? Especially if I've got the negative in front. And that's where you would need to actually change the sign inside there. You need this x to be negative in order for these two negatives to become a positive, and the square root of 1 is 1. So you put in a negative 1 and you got out a positive 1. What point is that? Let's see. Negative 1, positive 1. This is going to go this way. Okay? So if you have this blue line to start with, what happened to this one? It actually reflected this way. So this is reflecting over the y-axis. So we are going to reflect, or it reflects over the y-axis. All right, so we've got vertical stretch and shrink and reflections over the x and reflections over the y that we can now add to our transformations.